And you've got control, Greg, right?
Yeah, Lucian.
Yeah, Lucian's got it in the
And
background.
then I'll send it to you, Harry. So.
Okay.
We're live. Welcome, everybody. We'll get started in just a couple of moments. Welcome, everybody. As you get into the meeting, you will be placed in silence mode. As you have questions for the speakers, please make sure you use the Q&A section. Also, our social channels will be monitored. So if you have more comfortable to place them on Twitter or LinkedIn, leverage the hashtag ABBPGW. We'll get started in just a moment. Well, good morning, good day, good evening, everyone. I'm Lucian Fogoros. I'm the co-founder of IIoT World, and I'd like to welcome you to today's event, Optimizing Operations and Asset Management with Industrial Analytics and AI, brought to you by IIoT World and sponsored by ABB. Our team, led by Dr. Rudinsky, will monitor the online channel, so feel free to send your questions in the Q&A session, as well as the social channels, leveraging the hashtag ABBPGW. I'd like to introduce our moderator, Greg Orloff, who will host the virtual conference. Previously he was the CEO of Tangent Company, and Greg holds a Bachelor of Science in Engineering from Ohio State and a master's degree in Business Administration from Case Western Reserve. Welcome, Greg.
Thank you, Lucian. Welcome, everyone. Once again, thank you for joining us today. Now, before we dive into today's materials, please allow me to give those of us who are joining us for the first time a little bit of background. IIoT World is a digital media publication that covers the economic and technological implications of the transformation that is taking place as industrial IoT proliferates throughout the enterprise. IIoT World combines journalistic coverage with data analysis to expose the stories, players, trends, and innovations that shape the industrial Internet of Things. Analytica's 2020 report ranked IIoT World as the #1 global brand for industrial IoT. IIoT World was recently ranked by K-Core Analytics as the #1 global influencer on several topics, including industrial IoT, smart manufacturing, ICS security, SCADA, predictive analytics, and predictive maintenance. Additionally, smart cities has been in the top 5 positions for the last couple of years. Our mission is to help companies create a culture of innovation and connect to smarts, industrial technology, manufacturing, sensors, and the CXO decision makers that seek these solutions. Today, we're going to discuss a very timely topic with representatives from ARC Advisory Group and ABB that are poised to provide keen insights into the business benefits of using industrial analytics and artificial intelligence to optimize the manufacturing operations and processes. In these presentations and Q&A, we will discuss how data is a key resource from which to extract business improving insights. But industrial companies typically are only able to use 20% of the data generated, greatly limiting their ability to apply data analytics and improve business operations. We will address how industrial producers can optimize operations, improve asset management, and find greater profit potential through industrial data analytics and artificial intelligence. The key is to collect, contextualize, convert operational engineering and information technology data into action. Key topics that we'll cover today include obstacles to data utilization and how to overcome them, purposes for processing data at the edge versus the cloud, and the value operations, engineering, information technology data contextualization. I'd like to kick off our session today by introducing Mr. Harry Forbes, Research Director at ARC. Harry is the lead analyst for the Distributed Control Systems, DCS market. Harry has 30 years of experience in automation, power generation, energy management, modeling and simulation, advanced controls, and optimization. His research topics include DCS integration and architecture, smart grid, smart metering, energy storage, industrial wireless, industrial Ethernet, and emerging network technologies. Harry, we're excited to have you here today. The floor is yours.
Thank you very much, Greg. Again, I'm Harry Forbes from ARC Advisory Group. It's my pleasure to speak with you today And I hope you will contribute your questions and discussion through the chat during the presentations and also during our interactive Q&A later on in the session. For about the next 20 minutes, I'm going to discuss analytics from the view of industry. Looking at some of the opportunities offered by analytics, some of the unique challenges that analytics has to deal with in industrial operations, and finally briefly discuss the architecture and platforms that industrial firms and their suppliers are using to address these challenges and opportunities. Oops. First of all, I'll briefly explain the firm that I work for, ARC Advisory Group, and how ARC is involved in this area. Second, I'll discuss the value and challenges of industrial analytics themselves and how ARC recommends to approach them. Third, I'll discuss how ARC defines the digital twin, which is an important aspect of industrial analytics. And finally, I'm going to discuss the value of analytics to industrial firms in developing their digital transformation strategies toward fully data-driven industrial operations. So who is ARC to talk about this topic? ARC Advisory Group has been in business for over 35 years. We are a small firm of about 90 professionals located worldwide and focused on industrial manufacturing, infrastructure, and cities. ARC analyzes markets and technologies, and we publish about 200 market research reports on all kinds of topics, including industrial analytics, industrial IoT, and many others. We also serve end user manufacturing firms through advisory services and end user leadership community that we call the Digital Transformation Council. And these are some of the end user manufacturing firms that ARC has engaged with. Finally, through our own ARC forums and by participating in other events such as this, we hope to enable end users in manufacturing and suppliers to share and to collaborate. So let's turn to industrial analytics. Much of what I will be talking about today and the work has been developed by my ARC colleagues, Dr. Valentin Delou of ARC in Europe, and Mike Guilfoyle, a colleague from ARC in the Americas. And those two gentlemen and my other colleagues deserve the lion's share of the credit for this presentation and the thought leadership that they bring to this area. Let's talk about the building blocks of analytics and try to get away from the marketing, because analytics vendors are positioning themselves as competitively distinct. And this can make it very confusing market for end users. To get beyond that, let's step back and take a look at the fundamental building blocks of analytics. ARC views modern analytics as across four functional buckets that are combined in various ways to achieve a desired goal, which is the fifth building block of analytics: transformation. These building blocks are, first of all, a technology infrastructure, components for building, deploying, securing, and maintaining analytics in a business. Second, data, sources of value for analytics development, providing basically the fuel for business improvement. Third is methods. These are means by which analytics are executed and insight is developed. Fourth is output. These are mechanisms that allow a business to improve upon existing or historic processes. And the fifth, the objective, is transformation. This is a spectrum of value-based business change that's undertaken by the business. It's important to keep in mind this last building block of transformation. What may be transformational in one firm or organization might not be in another. It might be incremental. However, what is true in each case is that transformation represents a significant and improved departure from current or historic business strategies, customer relationships, business models, processes, etc. Within each of these five building blocks, there are many additional functional components that must be accounted for in the development of analytics. Let's take a look at some of them. Lucian, I'm having a little trouble advancing the slide. There we go. It's important to keep in mind that all analytics-based solutions fit within this framework and support one or more of these components. The main challenge associated with such a large scope is effectively navigating which components you need in order to transform. What your potential solution partners provide, what your legacy provides, and what the company that you work for needs to own internally and manage, and also how this will change over time. Many industrial companies have taken a technology-first approach when looking at analytics and how they apply to business problems. When this happens in digital transformation, ARC believes the approach often turns into the pursuit of some type of silver bullet solution or a proof of concept of the technology rather than the business problem. Instead, and this is an important point, to determine what analytics capabilities are needed, your organization should begin with the desired transformation and then work backwards to identify the appropriate components that are necessary in order to support it. Frustrated by this complexity, organizations need to really focus on defining a business need to justify the digital transformation. That defined business need becomes the stepping off point, excuse me, for digital transformation, which leads the organization into pouring its energy into figuring out how to scale from that starting point. And ARC sees a lot of the businesses engaged in the market, a significant segment, are at this stage. The idea is simple and a very logical step to take. The business needs provide the definition of what needs to be transformed. That, in turn, is intended to deliver a filter of sorts around use cases. The organization can then focus on the required data, processes, people, technology, and so forth. The output is a deployment that takes a repeatability approach to scaling. So if you can do it once, it's a matter of finding similar instances and repeating the same exercise. Transformation is about accumulating digital wisdom. Understanding where you need to learn and realizing that it's not just a technology fix, it's about applying a new way of thinking and data to customer needs and market signals. My colleague Mike Guilfoyle calls this slide the long ship of digital transformation, and this is the figure he uses to illustrate it. The key takeaway here is that the transition of core capabilities like analytics into standard operating procedures proves most difficult and time-consuming. That's to be expected. However, as companies begin to get more comfortable, you can also expect to see eventually a sharp acceleration in the benefits that this new way of business provides. Integrating customer perspective into analytics seems an obvious step for some companies, but it is not widely practiced. Industrial markets really lag consumer-facing markets when it comes to creating competitive differentiation by integrating customer insight into their analytics. The consequences of this customer misalignment become compounded as markets become increasingly digital and technical, and a company's speed of responsiveness becomes more of a differentiating value. Companies that can't dynamically adjust and change their operations to support transformation won't be able to keep pace with those who are more agile. Analytics is the main transformation tool that can bridge the gap between industrial operations and your customer expectations. It does so by addressing what we at ARC refer to as a customer relationship deficit, CRD. In doing so, companies are able to create a distinct competitive position and advantage. Customer relationship deficit is visible in many ways. If you lose bids, or if you lose long-standing customers, or if you have decreasing profitability, not matching production to demand, spikes in service level, contractual disputes, et cetera, et cetera. A company that uses its analytics to align and overcome CRD will have evolved their culture accordingly. First, they will have addressed their primary gap, which is the talent and skill needs of their people. This is the heart of the concept of IT-OT integration that is so often talked about in industrial infrastructure and smart city markets. As this approach is applied to analytics, there is no single best approach, but there are some guideposts to follow, and based on that, ARC recommends the following for owner-operators of manufacturing or infrastructure. Invest, experiment, and persist. Scale and return on investment will follow as wisdom accumulates, but there are some, it is likely you will need to adjust your investment strategy as you increase organizational competency. As markets tighten, the competitive need for digital competencies will increase, and if you haven't yet invested, you will find yourselves increasingly fenced out and unable to do so or find it much more difficult. Data strategy, cybersecurity, and governance are needed, but they will look different in the future. These policies need to account for shared data ownership among business units and between IT and OT, a democratized use of analytics by a broad group of users with different missions, internal and external data sources, and cyber-physical infrastructure. No matter the stage of digital transformation, account for the organizational and individual impact. Begin the planning process by accounting for people and ensure they are involved. And finally, for companies that lack a strong digital-first culture, start where volumes of data exist, where the process is well understood, but CRD problems persist. Familiarity with those foundations will help galvanize people into improving them. And finally, don't limit your objectives to operational excellence. As you gain competency, frame analytics business cases around your relationships with customers and any deficits that might exist in those relationships. Now we'll move on to talk on the next topic, defining the digital twin. Again, ARC is developing our definition of the digital twin in the industrial operations context. There are any number of aspects to the concept of the digital twin. There's a digital model, there's real-time data, optimization, a physical asset, contextual information, concepts from the Internet of Things, and industrial simulation. Can we boil all these aspects down into something of a more rigorous definition? Again, in an industrial context and over the entire asset lifecycle. That means design, asset operation, and asset maintenance. Here's how ARC defines it. We see three core elements of a digital twin. The first element is a digital model, contextual or characteristic data that can be thought of as the DNA of the digital twin. This information defines the properties of the real-world asset or process. Many suppliers, especially those in the PLM market, will assert that this is represented by a three-dimensional model of the asset. In fact, three-dimensional models are vital for certain activities. They are not a requisite of the digital twin definition in our case. More broadly, this information constitutes any type of model or data that can be used to define the identity of the asset or process, its form, its functions, and its relationship with other assets or processes, including business processes. The second element is real-time and operational data. This is data created during the life cycle, the O&M of the asset or process. While design models establish the identity of the digital twin's real-world counterpart, real-time and operational data describe its state and behavior. For example, a prototype digital twin in the manufacturing line tracks equipment health, equipment performance indicators, and statistical process control information. The type of information that is being tracked is highly influenced by the underlying asset or process. This element of digital twins aligns closely with concepts and technologies associated with the industrial Internet of Things. The third element is a holistic information model. The information model integrates these first two elements, the contextual and operational data. The model formalizes the properties and relationships and operations that can be formed for each data type that is part of the digital twin. When implemented, it federates data from the disparate systems that relate to the underlying assets or processes and acts as a single source of data for any application that requires access to the digital twin. If a modular approach is preferable, which it often is, an information model can be used to integrate the data coming from multiple digital twins, such as a fleet of assets across an enterprise or a supplier's installed base. ARC Advisory Group has found that digital twins of nearly all applications can be segmented into two fundamental groups: project digital twins and performance digital twins. The project-related digital twin facilitates the creation of a new asset, product, or process. It relies heavily on the design and simulation elements of the digital twin model. Whether used for new product development or during the design and construction of a plant, project digital twins can accelerate the program timing, give warning against costly errors in design, increase the fitness, and provide a performance baseline of an end product or asset. The performance digital twin is used to optimize performance as well as improve or enable broader business functions related to an asset, product, or process. Compared to the project digital twin, the performance digital twins are far more reliant on the collection and analysis of operational data. In process and discrete manufacturing, the performance digital twin mirrors the activity of a plant or factory. A digital twin can provide a detailed and comprehensive operational view, which can be individually customized and shared globally to support specific functions across an enterprise. Furthermore, the combination of historical data and simulation tools can be used to predict future behavior. Information, if trusted, coming from the digital twin, can be used to drive faster, data-driven decisions, reducing the need for unproductive verification procedures and for obscure tribal knowledge, which is so prevalent in many firms. One of the continuing challenges for capital-intensive manufacturing and infrastructure is to curate and maintain the information supporting digital twins over the full asset lifecycle. Traditional asset development includes asset handovers from developers, from EPC firms, from subcontractors, et cetera, to asset owners and operators. The EPC firms, in turn, for example, also have accepted numerous equipment and data handovers from OEM firms and their subcontractors. The challenge is to curate and maintain this information, keeping it useful to the long operate and maintain phase of the asset lifecycle. ARC advocates the adoption of a continuous handover approach to help converge the design and operational data digital twins, but this remains a major challenge. Finally, let's bring these concepts together into what ARC calls data-driven industrial operations. Why exactly do manufacturers and asset owners need this? Well, whether a company's overarching strategy is cost competitiveness, customer intimacy, product performance, or value through services, or some combination, you experience pressure to be resource efficient, to be sustainable, to be flexible, to be agile, and your assets must be operated safely with a long life and with high reliability. Reaching a few of those objectives is a challenge, but reaching all of them at the same time represents truly differentiating performance. Strategic decision-making in industrial operations that leads to this differentiating performance is very challenging. All the data you need may not be available. Some of the data may be inaccurate or may be out of date. And optimization requires the use of complex algorithms. In addition, the human mind, mine included, tends to make errors and to apply cognitive biases. A step toward improved operation and improved decision-making is getting access to information based on accurate data. First, the data needs to be contextualized to make sense when analyzing it. To provide context, data must be organized according to uniform and hopefully standardized information models. That is, organized according to an asset hierarchy at a minimum, and possibly according to process, transaction, material, and people manipulating these products or processes. Second, in order to be exploitable, data quality and integrity are essential. Data must be consistent, accurate, and up to date. And this can require human intervention, and the key aspect is to assist that human intervention by technology to make it as effective as possible with the minimum effort, because the people who intervene in these situations are scarce, very scarce resources. Ultimately, to optimize your operations and respond to pressures in the competitive marketplace, companies require tools that can make optimizations that human beings cannot make in their own minds by themselves. Important areas that can benefit from this kind of support are operational excellence, performance management, asset integrity and asset performance management, risk mitigation, safety, sustainability, energy efficiency, supply chain, and so forth. Optimization can require a combination of data mining, of additional data contextualization, categorization, mathematical optimization, application of AI and machine learning technologies. And recent developments in cloud computing have made the employment of these mathematical methods more easily accessible, but that does not make them a panacea. They must be informed by a deep domain knowledge that includes the industry knowledge and the underlying sciences that and engineering sciences that support the industry and the process. Quality of the optimization results further rely on data quality and data integrity. And the value of those functions is not only that they're likely to provide an optimum for the next time window or the next period of operation, but that the result is free of the cognitive biases that we human beings suffer from. As I mentioned before, maintaining information and information integrity over the whole asset lifecycle, from design through operation and maintenance, is the key enabler and a key challenge, which at ARC we call ALIM, Asset Lifecycle Information Management. In the United States, the NIST, National Institute of Standards and Technology, has estimated that 4% of the total capital expenditure done in the United States is lost through poor asset information alone. If that's so, how much do owner-operators invest in this area? In my opinion, probably not enough. Here is an architectural diagram of an industrial analytics platform used by the European chemical firm Evonik. Note in this diagram the presence of some of the elements that we have been discussing, such as the use of design and operating data, a set of structured data models, combined with simulation capability and behavioral models. All of this is serving a number of different communities who are working in different roles within the firm. My European ARC colleague, Dr. Valentin Delou, has identified Evonik as an industry leader in this area. If you examine commercial industrial analytics platform solutions, you should expect to find many of these same elements in these products and solutions. Specifically, Dr. DeLu estimates that the ABB Ability Genix Industrial Analytics and AI Suite could contribute improvements in the following areas across operational domains, and that is the broadest sense of operations, maintenance, energy management, sustainability, HSE, etc. More complete, up-to-date, and accurate asset information, and improved information integrity. More accurate and timely awareness across the enterprise of performance in the operational domains, faster analysis and problem resolution through better contextualization of data within and across operational domains, timeliness and quality of operational decisions based on that improved information and improved information quality, and a broader range of information sources. Reduced workload related to OT and IT integration, as well as more availability for in-depth analysis. And finally, improved cross-domain awareness and insights. My colleague, Dr. DeLu, has written a report on this topic, which is available to the public. With that, I thank you all for your attention, look forward to the questions, and will turn back the floor to our moderator, Greg Orloff.
Thank you, Harry. There were a lot of valuable nuggets in this presentation. I believe attendees are going to perhaps want to go back and watch this one again. Thank you, Harry. I think the fundamental point that always strikes true to me is the business needs have to drive the direction for these types of projects. It doesn't matter how fast you're paddling, rowing, or driving. If you don't know where you're going and why you're going there, the destination is going to elude you. So I'd like to now introduce Rajesh Ramachandran, who is the Chief Digital Officer at ABB. In his CDO role, Rajesh drives digital strategy, thought leadership, and execution of ABB Industrial Automation's digital portfolio and business growth. He brings 30 years of global leadership experience with a record of building and transforming technology and innovation-driven businesses across India, the United States, Europe, Middle East, and Asia Pacific. He has led strategic transformation programs with CXOs of Fortune 500 companies to strengthen digital and Industry 4.0 value chains. Rajesh, welcome. The floor is yours.
Thank you, Greg and Harry. Hello, everyone. I'm very pleased to be part of this IIoT virtual conference. ABB is one of the very few organizations who had the privilege of spearheading all the 4 industry revolutions by means of addressing the industry needs on all the 4: electrification, motion, automation, and digital together. As a leader in industrial automation for decades, and more than 125 years of industrial expertise, ABB has been serving customers with its deep domain expertise for safer, smarter, and sustainable operations. Whenever we think about how do we optimize the assets and operations in the industry, how do we remove this puzzle of optimization, I always relate this to a Rubik's Cube. Imagine you have a Rubik's Cube in your hand now. Most of us solve the Rubik's Cube, or perhaps tried for solving it many times. It can take sometimes few minutes, it can even take hours, and may not even solve it. But imagine if you had 3 more things in your hand. It's easier, faster to solve it. First, a cross-dimensional and holistic view. Second, a proven algorithms based on different data patterns in terms of how we can solve it. And third, of course, the speed. In fact, the same is applicable even to optimize the industry operations and assets. Of course, the complexity here is multidimensional, multivariant, and even the scale needs to be manifold, from an asset to a unit, to a plant, to an enterprise, to the cross enterprise. If we have to look at, let me get this working, moving, yes. Possibly I moved a couple of slides back. Let me go back. There's a lag. Let me just get the slide back. Okay, hopefully it comes back. So we should be good. There's a lag, so please bear with me. Okay, good, we are set. If you want to look at what should be best way to look at solving this industrial Rubik cube, I believe there are three key aspects that will help us to make the optimizations of assets and operations much easier than what it looks. And Harry also talked about the value of the data and also the contextual data and information model. We call this as an X factor in ABB. It fundamentally talks about the combined value of the operational data, the OT data, the design data coming from engineering systems, the functional data that's coming from the IT. If you contextually integrate these three different systems data, the value of the data exponentially increases. And we believe the foundation of industrial analytics and industrial artificial intelligence is this contextualized data. This X factor helps us to unlock the remaining 80% of the data that is today, which is not used in the plant, which is not used in the enterprise. And it helps to turn into actionable insights at the right time, thereby helping them efficiently to excel on the performance and optimize the cost. Let's take an example to appreciate this. Right? If we take a simple example of critical assets, let's say a turbine or pump or compressor, the OT data tells how this asset is performing along with its health indicators. The ET design data gives the design integrity of how well or poorly it's performing compared to its design specifications and how compliant it is to the safety integrity limits on safe operations. And the functional data coming from the IT systems such as SAP and Maximo, the different asset management systems, it indicates how to keep the asset performing at a desired condition with the right maintenance strategy, the right spare parts inventory levels, the right risk and investment planning for CapEx and OpEx, etc. In fact, as per ARC illustration, only 18% of the asset failures are based on the age-related failure patterns. But the remaining 82% of the asset failures occurs mostly due to the impact of the related assets, the process parameters, the lack of adhering the critical asset management and reliability practices, ignoring key management of change and key recommendations. These findings demand that the various asset data and information to be analyzed as a contextual system for both prediction and optimization. The moment we get this contextualized data applied with industrial analytics, which is fundamentally the combination of analytics with domain expertise, we can drive the diagnostics and prognostic analytics to actionable insights. But going further by industrial AI, which I will certainly deep dive in a minute, a combination of domain expertise and the artificial intelligence machine learning techniques can move to true predictive and prescriptive analytics for optimization. And the benefit of contextualized data applied with industrial AI is not only for optimization and prediction, but it is also addressing the needs of various different users and roles, whether it's an asset reliability engineer or maintenance engineer, whether a financial controller for doing the asset investment planning, or whether to look at the operations engineer to look at the operational loss prevention because of the unavailability of an asset performance. It shows clearly that the need is to go with the contextual data to provide and unlock the value of data together with the domain. Let me try this time. It possibly moves 2 slides at a time. So the second aspect is the industrial digitalization needs what we call as industrial analytics and industrial AI. It unlocks the combined power of the contextual data, which we just saw, the domain expertise, and the technologies that makes this data pipeline as well as to mine the data and process, such as IIoT technologies, as well as the AI capabilities. It needs not just a technology platform. It needs an industrial IoT and industrial analytics platform that brings the combined power of the data, domain, technology, and capabilities. In fact, Gartner analysis says that by 2024, pure technology IoT platforms will exit because it is not going to solve the complexities of the industries. We need to have the domain and industrial AI as a core part of the platform to bring the value of industrial analytics and AI for the industries to optimize its operations and assets. Taking further on, the third aspect is the scale. It's not about just doing industrial AI as a pilots. It is about the scale. I guess it's possibly moving a couple of slides much faster than I could think of. Just bear with me. The scale is going to be important to unlock the benefits of the industrial AI. In fact, the McKinsey's research says that if you scale the industrial AI for assets and units, you will get close to 5% EBITDA that can be scaled. So the scale needs obviously a choice and flexibility of deployment, choice for us to choose for different roles, to be able to start with the modular way on what specific areas that you want to start, whether it's an asset integrity or whether you want to start with operational performance and so on.
Rashesh, happy to advance the slides for you. You want me to advance it or move back one slide?
Can you move back?
Yes.
I think there's a bit of lag here. Yeah.
One more?
Yeah, you're good. Thank you.
Oh, here we go.
So what we have seen with the customers is when we look at scaling, it's also not about technologies and functionalities, but it's also the business models. We should be able to start addressing a specific value driver for the customer with a business model that can give the quicker the ROI and become self-funding to go on a larger digital transformation program. Can you go to the next slide, please? So when we see this being implemented, organizations traditionally taken an approach of buying set of tools and trying to put together and solve the industry challenges that you see in the left side, whether to reduce the unscheduled trips or reduce the operational risks, but still not able to solve the key operational excellence outcomes, whether it is asset integrity and performance management or safety and sustainability or supply chain optimization or operational performance. And that's because many times we keep our effort and time on bringing the data, which typically more than 80% of the time is taken for bringing the data together. and using this complex technology software cluster. Can you move the slide, please? Imagine that you are able to bring this together as a comprehensive suite, which still modular because you don't want a big elephant, but you would like to have a comprehensive suite that addresses all the needs, starting from integrating, contextualizing the data, modeling the information model that Harry spoke about, and also bringing the pre-built analytics and pre-built models to optimize and deliver. That helps us to directly address the operational excellence business outcomes. Next slide, please. And we believe that that is possible only if we embed the domain expertise right into the data value chain. As you can see here, the three major the data systems, operational, engineering, and IT networks, and of course even the data which is outside the enterprise, to bring all the five aspects, integrate, contextualize, model, analyze, and deliver to optimize, should have the domain expertise built as the digital twin and the information model right into the platform to provide the four key value drivers of digital, whether it's operational performance or asset performance and integrity or safety and sustainability as well as supply chain. And that will ensure that the focus is for driving directly the business outcomes rather than solving the technology puzzle. Next slide, please. With that, we believe that we could drive directly the business outcomes that will help customers to keep up their assets of the higher efficiency and utilization, ensuring that they get the higher operational excellence and efficiency, ensuring to address the regulatory compliance as well as to give back to the society on sustainability, but also keeping the right inventory levels, right supply chain efficiency across the different industry needs. Next slide, please. If I just take just two examples before I wrap up, just take an example as the system of assets anomalies. As we talked about, asset failures are not just based on a single asset. It is based on the operational patterns. Imagine if you are able to bring the data that gives the information from the design, technology, as well as the functional and real-time data from different systems. Contextually having that data with the system anomaly detection that could avoid the system failures by analyzing and predicting using the industrial AI on the operational patterns and avoid the upset condition for both process as well as assets, thereby reducing unscheduled trip by even 50%. Next slide. Taking just another example as critical assets, right? As I said, it has to scale from an asset to a system of assets to the plant. The industrial AI today has proven its value for predicting and optimizing critical equipments by both monitoring in real time as well as applying the contextual data for defining the predictive maintenance strategy as well as reducing the wind-up cost by 25 to 30% and keeping the availability on 20% increase. It's not only, next slide, it's not only about the assets and system of assets. If you go to the next slide, you could see that it can be used even for tracking the opportunity loss of the production, process reliability losses, the people integrity losses. You could look at tracking all the different losses and hidden losses to reduce that by 10% across the value chain on the production, across the auxiliary chain such as utilities and energy and catalyst, to ensure that we identify as well as manage the process inefficiencies. To summarize, if you can go to the next slide, to summarize, we believe that the industrial analytics and AI suite plays a significant role of filling the gap between technology platforms that we have, which solves the problem of bringing the data, but to contextualize that as well as unlock the power of the true value of the data to insights. It's extremely important to have a strategy that is aligned with a comprehensive as well as modular approach of industrial analytics that brings the combination of data, domain, the technology, as well as AI, applied as industrial AI with domain expertise, not just limiting ourselves on the physics-based modeling that we used to have, which can work only for a single physical phenomenon, not for operating conditions, or not just purely a data-driven machine learning models that will need a big data set, still the accuracy cannot be good enough. So as ARC mentioned, Harry talked about the digital twin of both an information model, contextualized data, bringing the combination of domain as well as AI, the power of AI together as an industrial AI. We believe that it can bring immense value to the industries for transportation as well as smart cities to get the next leap of value of our data and digitalization. Thank you.
Thanks, Rajesh. A powerful presentation as well. I think when you're moving past the thrilling days of yesteryear and physical-based monitoring into leveraging these types of technologies, artificial intelligence and otherwise, it's opening a tremendous amount of opportunity for process optimization. So thank you again. Now it's time to transition into our Q&A portion of today's session, where we will entertain the myriad of questions that are coming in from the audience. So thank you all for your engagement. It always makes it that much more value-driven when you folks are engaged as well. And as a reminder, we have two options for submitting questions today. You can use the Zoom Q&A tool, or you can submit them via Twitter using hashtag ABBPGW. So I'd like to invite everyone to reactivate the cameras, which you're already doing here. You're a step ahead of me. And we will dive right into some of the Q&A here that's coming up on our Q&A session. So let's kick things off here with, I had a question. This came from Thomas. Rajesh, what role will new technologies such as 5G and edge compute play in enabling the data transformation about which you spoke?
Certainly, as we talked about, the data is the center of what is needed for achieving the value of industrial analytics to unlock the hidden intelligence. We see that the edge computing today is going to be frontier in terms of how do you bring the optimization closer to the process, optimization closer to where the assets are running. In fact, in ABB, we have as much as focus for looking at the need of computing, not just on cloud, but also bringing to the edge. And we believe that any solution need to be able to run across the device, edge, as well as on the cloud. The technologies that we see on edge, as an example, helps us to be able to bring not just us pushing the data, but also compute and optimize it closer to the process. The technologies such as 5G that we see are going to connect and going to eliminate some of the big challenges we used to have, that every assets need to be wired in terms of to an engineering system, in terms of our controllers. With a 5G, you have an ability for getting the incremental real-time data directly to where you want to compute.
All right, thank you, Rajesh. I've got one I guess, kind of a fundamental question that came in. I'll throw it out to both of you. It says, can you explain what domain expertise significance is in simple words? So I think that was thrown into possibly both presentations, but if you could just give your bird's eye on what that means to you, that would be great.
Okay, you want to take that one? I could throw something out there, Rajesh, but
please go ahead, Harry. First, I will augment.
I'm shooting from the hip here, but what I think it means is a combination of understanding the manufacturing processes or processes at a deep level, the operational processes at a deep level, and the business objectives as well. It usually comes from experience in the operation itself. But why is it so important? It's important because it provides, albeit with certain cognitive biases, as I talked about, that all human beings have, it provides a very broad context for people who are looking at a problem or a question. So that kind of background is essential for an overall program. In a way, what I would say is a lot of times a domain expert can, as a mathematician would say, can shrink the feasibility region so that you don't focus or try to chase after solutions that are essentially infeasible.
Yeah, sure. Harry, if I can add there, the domain expertise can be seen as you have a bunch of consultants who have worked on the operations and they have a knowledge of working with the customers. Of course, the core domain expertise is always with the customers, but working with them, you bring a lot of knowledge. But keeping not just in the brains, if you want to bring that in your software itself as your suite, imagine you can represent a simple digital twin of an asset just as an asset with certain attributes and the real-time data. But if you would like to make that the way that ARC recommends as a digital twin, as an information model, what we call as asset information model, that ensures the information integrity of the assets from various different angles. We call this asset 360, whether it's from the asset from the safety angle, whether it's operations, whether it is asset from the maintenance strategy, whether it is on a reliability, whether it is on the asset from the financials and investment, or the assets from in terms of how you look at its own life extension. All this needs to be obviously seen with the business processes and manufacturing processes to be able to define what we call as the industrial cognitive model, which is the core of the GenX. Unless we understand the domain and industry processes of a specific industries, we cannot build this data model. Organizations have taken years for and millions of money to build this, but they cannot extend, they cannot evolve it. By bringing that domain expertise in the form of industrial and manufacturing and business processes right onto your data model or the information model, to combining all the 8 core business functions: assets, operations, projects, sustainability and safety, business insights, reliability, you bring that together, you obviously create an IoT to an industrial IoT, and AI to an industrial AI.
All right, excellent. Thank you both. It was a good definition. So this one, we're going to jump to the topic of security a little bit. It says, in terms of security, there are a lot of challenges scaling and implementing the typical VPN approach to collecting data from disparate systems and devices. Do you agree that this is a key challenge, and what are industrial companies doing to address these challenges?
I can.
Yeah. How do you want to go first? I can go as well.
First on that, not being an industrial security expert, I take what I say with a grain of salt. I have some colleagues who focus almost exclusively on that area, especially with regard to industrial control systems. But in general, the approach has been, I agree, the scalability and manageability of VPNs is a challenge for people, and it's not just for data extraction. I've seen a lot of folks struggling with that for remote diagnosis and other kinds of remote services that they want to provide or they want their suppliers to provide. The approach that I see is people developing those kind of services using more standardized sorts of technologies, like vendors will supply OPC services, for instance, and other kinds of services as opposed to VPNs. It depends on the industry and what the requirements are within that vertical industry. Obviously, we take different security approaches, and it seems to be an issue, an area that is always gaining importance, even in industries where it was not important, so to speak, a few years ago. It's becoming much more important for reasons not just of critical infrastructure, but protection of intellectual property and the kind of increasing threats that are represented by what we euphemistically call state actors in the industrial espionage space. So your mileage may vary depending on where you sit in the industrial space or the infrastructure space. But I see companies like Evonik and others building their infrastructure on multi-vendor standards and trying to use that as a way to get past the proprietary aspects of VPNs and legacy systems.
Yeah, if I can add, in fact, the ABB is one of the very few companies which have addressed the security from both on how do you secure your systems, but also that how do you ensure your information as well as your IP is secure, right? When you are looking at your processes, your data going to cloud, or even it's a private cloud, or even you are looking at different system connected in on-premise. It's very important to address the, when we look at the OT-IT conversions for solving the problems to optimize for using analytics, the same thing applicable for the OT-IT security convergence as well. And we have seen that it needs a reference architecture, and ABB is very committed with our customers to ensure that they get, when they go on the digital journey, they have clear guidance of how they move up in this OT-IT convergent security using our reference architecture, which is published, which is available, which also has a clear steps approach, the three-wave approach of how do you get your OT security in place and ensure that they're addressed, and how do you then move on to an OT-IT convergence for monitoring and look at it also the threat modeling and analytics as a three-step portfolio, which I believe is extremely important because we have been sometimes seeing that in the industrial control system front, even just applying and keeping up the latest patches of operation systems has not been foolproof. So it's very important for us to ensure that before we go on to a digital journey, ensuring that the reference architecture is clearly in place. Of course, the simple VPN approach of pushing the data or 5G approach can lead into disasters unless we ensure that we secure it at the device, at the edge, as well as on the cloud.
One other thing I would say, Greg, is one advantage that is coming in a way in security is potentially through more modular types of systems. And that can be a lot of chemical firms, for example, are wrestling with integration of much larger number of skid-mounted systems and skid-mounted process units. European firms are looking at going exclusively to modular production units or unit operations, and that offers some advantages in that instead of having kind of an open network where anything is fair game and you have to firewall it off, there's a modular approach to the production so that compromising one part of the system doesn't necessarily compromise all the others.
Yeah,
I don't know per se that that's the major driver for modularization in their case, but certainly one aspect of it. There are many other advantages of pursuing a more modular approach to production, and I imagine that carries into security as well.
And I also believe that, and I also believe that there is clearly now we are ahead of some of the challenges that used to be there a couple of years back on the cyber security for OT. We are far ahead of that in terms of an ecosystem today available. For instance, ABB with the industry leaders have an OT CSA cybersecurity alliance, which represents the players of the best of the leaders who bring the pre-integrated and tested solutions of how do you take the whole data value chain secure with respect to the cybersecurity.
Got it. Well, let me piggyback on this. It's tangentially related possibly, but I'll throw this to you first, Harry. This is a question from Thomas. He says, in terms of digital twins, does it make sense to have one for the manufacturing line and a separate one for the supply chain process surrounding it? Or is it best to have a single digital twin that includes the entire process from raw material to finished goods?
One point I tried to make there, maybe it didn't come out as clearly as it should have, is that for many operations, you want to have an asset, that asset information, that contextualized asset information model would enable you to do both of those things, so that your information models for both the design data and for the operational data would encompass, would be hierarchical enough so they could incorporate even single assets that might be critical, as well as larger systems like a production line or a supply chain. So the key is, I think, to define those models and relationships so that in effect you can build information assets that do not necessarily, that are usable in a number of dimensions, not just for single dimension. So that hierarchy of asset information models and data collection is part of it's the hard part, but that is what makes it useful for multiple different disciplines and parties within the end user firm, be it, you know, operations or sales or whatever, and also makes it potentially usable and useful to the customer base. So a hierarchy is the answer. I don't see it as an either or.
Got it. Thank you. So Gary has an interesting question. This is, what's your view of the current barriers in having AI and ML algorithms directly control and change processes within a DCS environment for truly autonomous operations? What's happening in industry to reduce or remove these barriers?
Well, I can discuss that a little bit. The types of systems that are managing production now, you know, DCSs and PLCs and to some extent industrial PCs are not really designed to support those kind of technologies in the native space. I mean, there's certainly, they can support them in some kind of complementary or close coupled operation. But one of the challenges that manufacturers, especially in the process manufacturing space, which I'm more familiar with, they have a problem with the fact that it's very difficult to refresh the technology at the, what we call the level 1, 2, the process automation or production automation level. That's really now represented by a DCS controller or a PLC. That's one of the barriers. I think that is being people are working on lifting that barrier through more open automation systems. For instance, the Open Process Automation Forum, which many suppliers, including ABB, are participating in, where we define more highly interoperable and easily refreshable automation systems. Another aspect of that I think will contribute there is the virtualization of many of these kind of functions now. We've traditionally implemented that kind of functionality within what are effectively embedded systems. If you look at a DCS controller or a PLC, it's an embedded system combined with a lot of end user or engineer configuration parameters. So this because it's a real-time system, it really has not been able to be virtualized in the past. Now with some of the new virtualization and network technologies, such as time-sensitive networking, it becomes possible to do this kind of application in a virtualized environment. And we've really not seen a lot of products at present because these are still emerging technologies, but the idea of doing those kind of operations in a virtualized environment could change the way that they are done substantially.
Yeah, if I can add also on what Harry mentioned, what we see is that today with this, the traditional Pseudo model is going off because of the fact that you could have the data coming from different layers to directly. So what we see is that the autonomous operations uh, can be defined. Of course, it doesn't mean that you just change the set point and the optimization and just things are changing. It can never be possible to do that. But many a times, the way that the control systems were engineered is that it's not only addressing the core control loop for keeping it stable, but also they were doing a lot of engineering for asset optimization were sitting there. And now with these technologies of whether you bring the model predictive controllers, for instance, Genix has an MPC, which can optimize the assets right there closer to the edge, as well as on APCs or on sitting on the control systems. So we take out the engineering and the information models of assets just outside the control systems, which you typically need to optimize not every milliseconds, you possibly need to do in every seconds or minutes, and then you push it back. So I would call that we need to have a different approach for bringing the autonomous for processes versus the asset optimization, which are at a different frequency of the data that optimization levels we need to drive it. And I believe that with the edge technologies today, and edge being not only for just pushing the data, but compute as well as edge AI, things like Genix MPCs can solve the need of getting closer to the control systems for bringing the autonomous operations.
Rajesh, when we talk about, you mentioned the sampling rates just now, so I want to pivot a little bit and talk about data for a second. Do you think that the huge amount of real-time data that IIoT is generating, is it sufficient for creating meaningful analytics? You think we need to do more, do less? Maybe expand on that a little bit if you could.
Yeah, sure. I think many times that, I get more data, more real-time data, I should be able to solve the problem. There has been a bit myth there. And I'm sure that after this session that both Harry and touched upon a lot and myself, that real-time data is one element of the solving the puzzle. That's obviously going to show that how a specific asset or a process condition is currently there performing on its indicators, which is very important. We don't want to be doing a traditional PI. We would like to work with the real-time data, but the context of analyzing is coming certainly from the not just the real-time data from the OT systems, but also from the rest of the systems. We have quality system that will be coming from the asset management systems or IT systems. Unless we contextualize the real-time data with the context data, we cannot drive the analytics for prediction and optimization. I would say that while it's important to get the IoT real-time data, it needs to be combined with the engineering as well as the functional data to achieve the desired analytics, prediction, as well as accuracy.
So if I piggyback on that for a section, maybe take a step out. How do you see ABB evolving in the digital space or further into the digital space from just an IIoT player? What does the path look like organizationally for you folks?
Sure. So as many of you and us will know that ABB has been it's an interesting place in terms of it is also an industrial software player, but also it is providing millions of assets or critical equipments, whether it is our ASIPods for marine industry or whether our pulp and paper QCS systems, or whether we are talking about analyzer and instrumentation or our gearless mill drives for mining. We provide a lot of large equipments. And these equipments are very critical equipments on the process. We could use just IoT for getting the data of how an asset is performing through the sensors. And we can do a condition monitoring of the asset to see the health. That's something as I would call as the first level of digital services, which we have been doing it for a long time. But that's not going to solve the problem of how we could optimize the process in which that asset is used. That's not going to solve the problem of the value drivers customers have as a larger problem set to be addressed. So we took the next step on that 4 years back on forming a strong digital organization that took the advantage of our core strengths on automation, which we are leaders for years, on taking our control systems, on top of that building both asset optimization and operational performance optimization solutions running closer to the control systems on the L3 layers. That helped us to be able to solve specific problem, energy efficiency, or looking at specific predictive maintenance problems. But when you want to go next on solving the 4 key major digital drivers, whether it is an asset performance and integrity management, whether it is an operational integrity and performance management, or supply chain optimization, or complete sustainability and safety, where we see that close to about 40 different value drivers for each of these value pillars, that needs to be looking at the customer's landscape. It's not only about ABB's control systems and ABB's assets, it's customers' wide variety of systems, assets across the landscape. So here we moved from, that's where we moved from an IIoT to a control system, automation-centric digital solutions to now true integrated systems, which is Genix as an offering which we launched, which sees from the customer value drivers. It can integrate both ABB and non-ABB systems across OT, IT, and ET, and it has a pre-built analytics models, pre-built AI/ML models, tuned with the domain expertise, as I mentioned, as an industrial cognitive model, and can drive direct outcomes for solving some of the very complex optimization solutions. We had advantage of going through this with our ARC colleagues on showing what we are able to bring as unique on this solution. Especially, we just talked about a problem of can you have 2 different digital twins for the core process as well as the logistics? Of course, that will be the reality in an industry, but Genix having a component such as system twin integrity, which actually ensures to map it and build a hierarchy for solving the problem of how do you look at a holistic view of optimization. So I believe that this way of looking at an comprehensive as well as modular takes us to solve much more complex problems on broader digital transformation programs to our customers.
Yeah, thank you, Rajesh. Maybe to jump into that nuance of the ecosphere of the client and that perspective, there's a question here from KSN, and he says, process optimization is different from maintenance optimization. What kind of parameters will be taken into consideration to analyze the machine inherent conditions and health of the equipment? So maybe I'll throw that to Harry first if you want to comment, and then we'd love your perspective on it as well, Rajesh.
Well,
Harry, you want to go first? Yeah.
Well, I'll go first. It's not an area I can speak to extensively,
okay.
But when you talk about maintenance optimization and process optimization, you're kind of looking at over a period because for many operations, the production activity depends on achieving certain targets at certain times. And the maintenance operations need to be managed within a certain window. And I think that's true in both process industries. So there is a need for obviously coordinating the optimization of those 2 activities that may become more complex as there are kind of incremental activities that may have a marginal effect on production at times when you maybe need more production, and the incremental production can be valuable. So in a way, when we talked about CRDs and customer driven customer deficits. It's instructive maybe to think, or for maintenance to think of themselves as serving the customer of operations in that case. And in some cases, that's really the case because the organization may be different, it may be outsourced. But serving them as a customer and understanding what their issues are with the normal maintenance practices. In terms of the diagnostics, I probably shouldn't speak to that. Maybe Rajesh, you have some other things to say about the issue.
No, I think you covered it well. But I have seen that it's, again, I go back to that same Rubik cube multidimensional. I have seen when you like to look at process optimization and the asset lifecycle extension and optimization, I don't think we are able to see that completely different. Of course, they have its own unique challenges and to be addressed. When you look at process optimization, we look at process performance. We look at it in terms of the energy efficiency and catalyst consumption, losses prevention, process safety, value stream analysis. These are all the key aspects when you look at it for operational performance. At the same time, when you look at it as a process safety, obviously you have to look at it also in terms of how you are maintaining your assets, what your strategies, how much excursion has been done in terms of the recommendations. So we have seen that it is extremely important to look at, especially for the asset-intensive process industries. We have seen that you need to look at both the angles when you want to look at real optimization. And otherwise, we have seen that people are looking at just addressing the control loop for the process, but they don't look at the asset loop. And more importantly, now we need to go beyond the asset loop to enterprise ecosystem loop. It's absolutely not going to be the best yield that they will get it in terms of optimization.
Got it. Thank you both. This is a little question for you, Harry. We're jumping back into the topic of digital twins a little bit. Why or when specifically does an equipment handover become a difficulty for a digital twin?
It's a chronic difficulty. I think over years and years, the technologies involved in handovers have changed dramatically with the evolution of technologies, but it still remains an issue. And I think the reason it remains an issue is because if you look at the different parties working in a value chain, they have different business objectives and different competencies. So if you look at a owner operator, be it a chemical company or oil company or something like that, or automotive, they're interested in operating and maintaining the asset and making sure that it's highly productive. If you look at an EPC or to some extent a system integrator, they have that objective, but they also have an overriding objective, and that is completing a workable plant or subsystem and delivering it to their owner operator. So that drives their particular skill sets and the things that they practice. And so there's a gap there that has existed for decades, and efforts to bridge that are ongoing. And it's really up to the end users, I think, to be more proactive in the way that they manage their relationships and their almost the contracts as well with EPCs to help improve that situation. But I don't think it's going to go away, and it hasn't gone away despite all the advances in the technology over the decades.
But I also believe that, yeah.
Go ahead, Richard, please.
Just add, but I also believe that while the OEMs and the EPCs play a significant role of fundamentally getting what we call as the design integrity part of the digital twin, as Harry also covered in his presentation and in the light of Genix, how it implements as well. The digital twin we call as a system digital twin is looking at both design integrity as well as the process integrity and technical integrity, right, together, which means that it cannot be provided by whether a EPC or a OT player in isolation. It is to be implemented in the hierarchy of an asset information model in a specific owner operator. So obviously that fundamentally needing a solution provider working with the customer in tandem as a collaborative model to build that what could be the more meaningful digital twin that truly represents both the design and operating conditions to be able to stimulate as well as to be able to optimize. I don't think one of the ecosystem can just solve it.
No, that makes a lot of sense. You had mentioned as well here, I think a chemical company, I believe it was Evonik, as being a leader in your presentation earlier. Why do you think that specific company is ahead of its peers or maybe on the top of their game right now? Could you share some of your insights?
Yeah, I would mention one thing that certainly drives them is I think they've had a role on the kind of the customer deficit situation because the product mix that they create is very complex. So that when you have a lot of different products like that and your production metrics get very, very complicated, then you start to, it gives you a lot of opportunity to address customer deficits. Another thing that I mentioned earlier that I think is very important is their focus on modularity. And that is from their perspective, their focus on modularity of production and production, automation, unit operations, all that is not driven just by the technology or necessarily just the economics, but what they see there is a business value in terms of agility and speed to product. So again, we were talking about beginning the journey with a business objective, and they define one of the key business objectives for Evonik in terms of modularity, and they explained this at our ARC forum in February when people were still meeting in person. The objective is to dramatically shorten by about half the time to develop a new product in their market. So if they can they believe if they can improve this modular technology and utilize it effectively, it can dramatically shorten the time to create a new product and deliver it to their customers, which is important for them and their customers.
Yorio has a question here. I'll throw this to you, Hirsch, Rajesh. Says, IIoT has been a hot topic for a number of years, but the adoption seems to still be limited to bigger players in the industry. What do you think is preventing wider adoption of the technology? And what do you think the future outlook is for the next 3 to 5 years?
Yeah, sure. I guess while the IIoT has been a buzzword for quite some time, I have seen even as a technology player, I joined APP about 18 months back, but I have been also in the IT world where building the core technology platform for IoTs. I would say the maturity and performance and scalability of the IoT platforms also evolved over the years. So while things started, people also learning it when you put on the context of the industry. I would say that the transformation from a pure IoT, which was used for building automations and transportation and so on, to a real need for the industrial IoT has taken some time because of the core challenges that we have it in terms of you still have the different layers of L1, L2, L3, L4, which is very complex, or which needs to ensure the trust barriers between different levels. B, also the amount of data that's needed even to get a basic sampling data pattern for analyzing and optimizing. So I would say that has been also the technology is evolving, but today the IoT and industrial analytics and AI has definitely far ahead of what the industries can easily adopt and drive the efficiencies. On the other hand, the organizations also were ensuring to get their data maturity and information maturity. Right? People were able to still solving the puzzle of data silos to get it in one way. And you can't solve, and just with an IoT technology, you cannot solve your optimization problem or your industrial insights problem unless we are able to get the data integrity in place. I see that in last 3 years, the adoption of moving from a pilots to large scale implementations of IIoT and industrial analytics have been extremely promising, and large companies across the sectors have been able to reap the benefits. What we see and the analysts say also is that now the next leap of adoption will be significantly faster than what was happening last 5 years. We hope the same.
Fantastic. Well, thank you. I think we've come to the bottom of the hour, and I want to thank everyone for taking the time to join our session today.
Yes.
We have several upcoming events as well. Stay tuned for Thursday, September 3rd at 11 a.m. Eastern Standard for how industrial players can efficiently respond to technology disruption driven by IIoT. And we have another session coming up September 23rd on IIoT in manufacturing, the virtual conference. So make sure to check out our events page and insights for upcoming content, events, and engagements. And stay tuned for details on the IIoT World VIP community launch. Or if you're intrigued and want to learn more, please reach out to info@iiot-world.com to get pre-launch information. Special thanks to our sponsors, AVB and ARC Advisory Group, for this educational session, and to our speakers, Harry and Rajesh. Outstanding contributions today, gentlemen. Thank you so much. If you have a suggestion for a topic or otherwise, sure.
Thank you.
No, thank you both.
Thank
If you have any suggestions on a topic or otherwise, we always welcome feedback, so please drop us a message and let us know. And if you like what you heard today, we invite you to subscribe to our newsletters, YouTube channels, and follow us on Twitter at IIoT_world. This concludes our program for today. Once again, thank you for joining.
Thank you.